This is preparation for exercise 12.6. You need to go over maybe chapter 3, section 3.6 of the quadratic formula. What determines the nature of the roots in a quadratic formula is the discriminant, which is the bit inside the square root in a quadratic formula, b squared minus 4ac. So in this chapter, I guess we're interested in a situation like this, where b squared minus 4ac is less than 0. That means the roots are not going to be real. Now, there's a fancy little theorem called the conjugate roots theorem, which states that if the coefficients of a quadratic are real, and if the roots are complex, then they must be the conjugate of each other. The same actually applies with irrational roots as well, but we won't worry about that at the moment. So we're interested in this here, conjugate roots theorem. So as an example, for example, solve the following quadratic equations here. So here the coefficients are real of this particular quadratic. The coefficient of z squared is 1, the coefficient of z is 4, and the constant term is 5. If you go and solve that equation, you will notice that the roots are indeed the conjugates of each other. So here the roots are minus 2 plus I and minus 2 minus I. Now, the next part of this section has to do with forming quadratic equations. And as far as I'm concerned, the easiest way to form a quadratic equation is this situation here. If you realize that the two roots, the sum of them is equal to minus b over a, and the product is equal to c over a. So where alpha and beta are the two roots given. So for question 11 here, this is taken from your textbook as well. Form a quadratic equation with each pair of roots, giving your answer in the form z squared plus bz plus c. So we have in the first example here, we have 2 plus or minus 3i. So the sum of the roots is equal to 2 plus 3i plus 2 minus 3i, that equals 4. And the products, if you work them out there, is equal to 13. So then to form the equation, you just write down z squared plus 4z plus 13 equals 0. And that should be enough to get you through that exercise, I hope.